Hey everybody, we're going to take a look today at different types of chemical reactions. This one we're looking at is called a synthesis reaction. Now the word synthesis basically means we're putting something together. Just like synthetic means it's man-made, synthesis means we're taking two things and we're kind of forcing them to combine into one. We're talking about chemically combining, not just mixing in the same container. So I've got an example you're going to see. This is zinc, which comes as like a gray powdery metal. And this is sulfur, which is more like a yellowish powder. Remember, it's a non-metal. And what we're going to do is we're going to force these to come together and make what's called zinc sulfide. Now, part of this is to see the reaction and some characteristics of it, and part of it is to actually see what the equation looks like that represents that reaction. So to write this equation, what we need to do is look at each thing separately. We don't want to look at the entire equation at one time, but we want to look at one piece at a time. Zinc is a metal, and there isn't really much special about it. Its formula is Zn. Okay? It's not diatomic. It's not something that has a little number by it. It's just zinc. So we have a bunch of zinc atoms. Sulfur is the same way, even though it's a nonmetal. Okay? We're just going to have S, because that's what we get off the periodic table. Now when these come together, we would like to just put Zn with S, but what we need to check are the charges. Okay? We need to look up on our periodic table and find out that zinc makes a +2. That means each zinc atom will lose 2 electrons. But the sulfur, it's a perfect match. It happens to be a -2 because it's going to gain 2 electrons. So if each one of those loses and gains 2 electrons, they make a nice perfect 1-to-1 ratio. Remember, if this equals 0, then I don't have to put any special numbers down here. There's really just one of each. And we don't write the ones in our formula. So this happens to be one of the simplest, easiest equations to make because zinc and sulfur go together in a nice, perfectly balanced way. But if this was not a 1-to-1 ratio, we would go back at the end and put the big numbers in front to balance the amounts. So zinc plus sulfur, make them react together and you get zinc sulfide. Now let's take a look at what that will physically look like. Okay. Here's a sample of zinc. It's like a dark gray powder, fairly heavy. Here's a sample of sulfur. It's like a yellowish powder and it's fairly light. What I need to do is put these together, and you'll notice when I dump them together, we don't see a reaction. Like we talked about evidence of chemical change, I don't see anything going on. I'm going to mix them up together, but a lot of reactions, you can put things in the same container, but it doesn't mean they are actually going to interact with each other. There's not really going to be a change. I keep mixing these up and I try to get something to happen, and it doesn't appear like a change is happening. They're just sitting together in a mixture. Okay, so what I'm going to really try to do is force them to react. And this happens a lot. We need to add what's called activation energy. Sometimes it takes a little trigger to make these happen. And what you're going to see in several different reactions are different ways we can trigger a reaction into happening. We need to add a little bit of energy that just kind of gets the whole thing started, and then usually the elements will take over from there and they'll all start combining or trading places or doing whatever change they're going to do. So right now I'm trying to basically smash this up so that you get as many atoms touching each other as possible. If I have big clumps together, then it's really difficult to get stuff inside that clump to perform a reaction because it's covered by things on the outside. We want to break this up into a really fine powder. More surface area means more atoms touching, which means more of a reaction. So I'm going to give that a try right there. Now, I'm going to take that amount of zinc and sulfur. This is not zinc sulfide yet because we haven't got them to chemically interact. I'm going to dump it into a pile. Okay, and now I have to add a little bit of energy. Lots of ways we can do this, but I'm going to add some energy with heat. This is going to be the activation energy in this one. And we'll see if it works. Sometimes it works well and sometimes it doesn't. Okay. Let me go ahead and light the torch here. I'm going to hold this kind of at the tip of the flame where it gets quite a bit hotter. There's a lot more oxygen out here on the edge of the flame to react than there is on the inside. You're going to see an orange color coming off. That's basically from the iron and the sodium that kind of infects everything else. But you see that color coming off like we saw in flame tests, and it's going to start glowing red. When I get it to glow red, I'm going to take that hot glowing piece of metal and add it to this pile and see if I can get a few of those atoms to interact, and hopefully they'll give off enough energy to make everything react. All right, we'll see if this works. Here goes. Okay? Big flash comes out of that. All right, I'm going to turn on the ventilation real quick. Let's take a look at. We're going to take a look at what's left. That bright yellowish powder now is zinc combined with sulfide, not in a mixture, but as a compound. It's zinc sulfide. It's something new. Okay, if you've seen flash powder like at magic shows, this is what it's made of. You see that reaction? That's the same kind of thing. The iron on this wire didn't really react with it. It just was something to kind of kick it off and get it started, that extra energy that was there. All synthesis reactions will look the same. It will be two separate elements coming together to make one new compound. Okay?